So today I'm going to talk through how I went about setting up this simulation. The bulk of what I'm going to talk about is the CHOP network and the audio processing that drives this. And then I will also show how to set this up and a couple gotchas for that. So what I'm going to do is I'm going to start a geometry object here and start to build. So the first thing we need is a CHOP net. I'm going to hop over to my motion effects view, and this is the editor for your CHOP networks. So what I'm going to do is bring in my audio. You do that by just use a file node. This is a file CHOP. So I'm going to bring in my audio. This is audio that I found online that I'll post a link to. It's just a free Creative Commons audio, so I'll post a link to that and give credit to the artist. When you bring in audio, it brings it in at its full length, which makes total sense, but I don't need like 3 or 4 minutes of the song. I'm only going to work on a few seconds of it, so I'm going to drop down a trim chop. If you watched my last tutorial on audio processing, some of this is going to be familiar. Spacebar and H on your keyboard, that will give you your the entire view, show you the full length of your song. I'm going to just use the handles in the motion effects view to bring this way back. And then I'm going to go to the end of my timeline. And if you don't have a play bar that shows up in your motion effects view, it's this toggle right here. So this shows me where the end of my timeline is. Also, you've got numbers down here at the bottom that also shows you. It's just easier to see the playhead. So I'm going to bring that all the way, maybe just a little bit past my full time range there. The next thing I want to do, when you bring in audio, it has 2 channels. Most audio that you're going to deal with is stereo. You might deal with mono audio, but either way, if you've got 2 channels, it's smart to delete one of them. It doesn't really matter which one, but I'm going to keep my channel 0, delete channel 1, and now I've just got one channel of audio. It's really dense. If you middle click on any chop, it's going to bring up this menu that's really similar to in SOPs. What I'm concerned about is this samples per second. Right now we have 44,100 samples a second, but we're working at 24 frames a second. So I'm going to do 2 things. I'm going to use an envelope filter, which is really standard when you're processing audio. What it does is, if I zoom out, you'll be able to see it really easily. It sort of traces your waveform and gives you a curve that you can use. Okay, so what I'm going to do is this is still at 44,100 samples a second. One of the nice things about the envelope filter is it also has a resample option. I'm actually going to give this more samples than we need, more samples than it may seem like we need. I'm going to give it 600 samples a second. Now what I want to do is I'm going to use the trigger chop, and I don't think that I've been able to go over this in any past chops tutorials, but it's a really useful chop if you want to sync anything with audio. And the way it works is it's got a threshold, and what it looks for is either increasing or decreasing values. And then at this threshold, when there's a value change, when there's an increase in your value, it's going to register one of these pulses. So I'm just going to turn off my envelope for a second so you can see it. And you can see as you start to play with the threshold, you get more or less registers of that trigger. To fine-tune this more, you need to dive into some of these other tabs. So the attack length, if you can see, like when this goes from 0 to 1, that's the attack. And right now that is happening over 0.2 seconds, I think it's seconds, not frames. I want that to be much shorter. My peak level, that's going to be, it's exactly what it says. It's the value of that trigger. So I'm going to leave that at 1. And I don't need my peak length. That is how long that plateau is. I don't need it to be long at all. I just want it to not be there at all. The sustain is going to be So the sustain level is just like the peak level. Like if you want this to sustain all the way at its maximum, or if you want it to sustain at its minimum, or anywhere in between. The decay length is sort of how long it takes to fade out, and the release is similar to that. If you had sustain here, the release would be sort of that knee of the release. But since our sustain level is 0, you're not going to see anything happen. The decay length, again, is how long it takes for this transition to go from 1 back down to 0. Let me pull up my audio again so we can sort of see what we're dealing with. And I'm going to I'm actually going to play the audio so you can hear it. So there's actually a lot going on in the audio that we're missing out on. Like I want more in these areas that are dead in our trigger. I want more going on there. And you can, oops, I thought I was in the wrong section. You can fine tune this some and you can get more peaks in there, but I've had trouble getting enough for my taste, at least with this audio and at least with this setup so far. That might be pretty close. I'm still like in here. These values are so similar. Let me turn on the deleted one rather than the dual channel. These values in here are so similar, and they're so tightly they're just so dense and so tightly packed in there that there's not enough room for this trigger chop to really to register the differences that I'm hearing in the audio. So a way that I came up with to help with that is there's a stretch chop, which will do exactly what it sounds like. I'm going to disable this for a second. Yeah. So the stretch chop will take your audio and sort of do a scale on the x-axis for you. But what I've done is I've stretched my audio out by a factor of 10, and this is in line before my trigger, okay? Because what I want is I want more. Now if we look at the length of my audio, I'm getting far too many value changes registered in this trigger. So I'm going to up my threshold. Not by that much, but again, it's a little bit finicky to play with these values, but you know, once you start to dial them in, you can. There's a lot of control to be had, especially if you add these stretches in there. So I'm going to say that is okay for right now. It may not be everything that I want, but for the purposes of me walking through how to set this up, that's where I'm going to leave it. And if we were to play this back, it's not going to be in sync with our audio because we've stretched it out. We've scaled it by a factor of 10. So what we need to do is to get another stretch. And this one's going to go after our trigger. And this stretch is going to, rather than be a length of 10, it's going to be a length of 0.1. Because, again, we scaled it up by 10 to begin with, and now we're going to scale it down to 1/10. And that'll get us back to that gets us back to our original the original duration of the song. So now if we listen to it and watch it, that's much more in line with what I'm hearing. I may be missing a few notes here and there, but it's okay. For a quick demonstration, it's gonna work for us really well. So this is part of what we're getting. We're getting the pulses, we're getting the registers of the beats, but what I'm looking for is I want there to be like almost like a stair step, right? So for every time there's a beat, because what I want to do is I want to iterate through a group of things. Like when the first beat happens, like 0.1 blinks. When the second beat happens, 0.2 blinks, and so on and so forth. So what I'm going to do is, there is a chop for that. It's called the count chop. Another really useful chop. And this is very similar. Let me leave that on. This is very similar to the the trigger chop. And honestly, I might have been able to just use this count in place of the trigger, but I prefer to kind of separate out those operations just for my own. It's just the way that I work. If you want to cut this step out and just go straight to the count, you probably can, and you'll probably have decent success doing that as well. This is very similar to what we just did with the trigger. It's got the same kind of threshold, and you can see what's happening is this says, okay, I've registered an increasing value right here, so I'm going to jump up 1. Up, there's another one. Jump up 2. There's another one. Up 3, up 4, and so on until infinity. Now, we don't necessarily want to go through infinity, so we can limit what we've got going on. So we want to limit our min and max, and I actually want to limit this to 100. So I don't even have enough values in there to get through 100. But that is exactly what we want. So for cleanliness, I'm going to drop down a rename and a null. And what these are going to do is this is going to rename my incoming channel from anything. That's what that wildcard is. It says, hey, whatever channel you have coming in, rename this to, I'm going to call it step. And if you have multiple channels, this wildcard will screw you over. So if you have multiple channels, be explicit about which channel you want to rename. If you only have one, the wildcard is perfect. And then I'm just going to rename this out. And now what I'm going to do is I'm going to hop to my geometry content, or my geo there. I'm going to do this. I'm going over to my scene viewer, activate my grid. And now what I want to do, just to show what we've done there, I'm going to make a grid and the boxes and the copy to points. And I'm going to copy those boxes to this grid. And there should be 100 of these because it's a 10. Oh, is that right? Is it a 10 by 10 grid? Yeah, so there are 100 of these. I'm going to pack them, pack an instance. So now I have 100 things. I have 100 packed geos there. What I want to do is I want to make an attribute create, because what we need to do is we need to get the what we've done over here in our motion effects view, this step channel. I need to reference that. I need to reference these values as an attribute. So I'm going to call this ref from chops. And you can do this several ways. This is just the way that I prefer to do it. I'm going to call this step, and I'm going to drag this, just grab the name here, grab the handle, and then just drag and drop it as a relative chop reference. And then if we go to our geometry spreadsheet, we can see that as we scrub through, we've basically got this counting attribute. So now what I'm going to do with that counting attribute is I'm going to color these just as a visualization. I'm going to have these cubes change color based on that attribute. Again, like everything in Houdini, there's probably a lot of ways to do this, but the way that I came up with was using a group expression. I think I need one more attribute in here. I'm just going to drop down a wrangle. So what I want to do is I want to create an ID attribute. So I'm going to say @ID. That's the way that you declare an attribute. So I said my ID attribute is equal to my point number, which is pt num. So all I've done here is create an attribute called ID and set it to the value of the point number. And you can, let me just do this here. You can see that point number matches the ID. You can also do that with an enumerate SOP. It's just habit for me to do it that way. I want there to be a group that only contains the cubes where the ID and the step attribute are equal to one another. My attribute create, where I created this step attribute, I don't want that to be a float. I want it to be an integer. And now then, in this group expression, set this to points. So what I need to do is say when my ID attribute equals my step attribute, be in this group. And it looks like that didn't, this actually did work. Our viewport seems to be kind of stuck, because what should be happening is this cube should be traveling across here as I scrub my timeline. And the way I know this is working is if I look down here in my geometry spreadsheet, right now this group, my group 1, it says that there's one point in that group and it's right here. And as I'm moving my timeline, that's changing. So I know that this is working. It's just that my viewport isn't cooperating. So I'm going to try to reset my viewport and see if that does it. Doesn't really like it. It's okay. We know that it's working. So what I want to do is have a color. This color is going to be my base color, so I'm just going to set it black for right now. And then I'm going to have another color that only operates on my group 1, and it's going to be 1. And so when I play it, sorry, there's noise outside. Okay, so it's working. That's working exactly like I intend for it to. But I would like there to be a little bit of a fade in those colors. The way to do that, or again, lots of ways to do it. A way that I've found useful recently is, let's get a solver. Pretty much any way that you do it, you're going to need to do it in a solver. That's a non-negotiable. But I really like this Labs blend color. It takes the colors from 2 inputs, blends them together like you would in Photoshop or anywhere, any compositing kind of package, and then it gives you this strength slider. So let's hop up so I can see it. And what this is going to do, so it gives us this trail. And if you don't know the solver, it works like a dynamic solver. This input is the previous frame, so this is taking the color from whatever frame we're on. It's taking the color from the previous frame and I'm adding it to the current frame, and I'm doing that sort of perpetually. So like the color accumulates, and if I want it to accumulate less, then I just pull the slider back. All right, and that's sort of where I'm going to leave this example. So that's half of the chop setup. Because right now we have it's just counting up in an orderly fashion. But what happens if we want something that's more randomized, right? We don't want it to go straight in order. We want every time that there is a registered impulse down here, we want to generate a random number. So let's talk about how to do that next. All right, so we're back in our chop setup, and similarly to SOPs, there is a very useful VOP that we can use. This is a VOP chop instead of a VOP SOP. It's a VOP chop, and if you hop in, it looks really familiar. This might not look familiar. These are different values that are sort of inherent to a channel rather than a piece of geometry. As similarly to in any VOP context, there are a few random functions that we have access to. The one that I've used is this non-deterministic random, and what that does, I'll actually do 2 of them. I'll give you the first random is going to be based on, and maybe this actually is a better one to use for our example. It asks for a position value, similar to SOPs. This V, this is the value. Basically, it's the sample value. So whatever incoming curve you have, it wants the value of that, and then you output the value of that. So if I just plug a random number into there, let me hop back up. And so I'm looking at our count and our VOP, or our random VOP. So we're getting a different random number every time. So we're, every change in our value, we're getting a slightly different rate. Even if it's just a very subtle change, we're getting a value. And that's because we know that random numbers are between 0 and 1. And all of these values are between 0 and 1. So what we want to do is we want to round those to integers, because we need integers for our setup to change those point numbers. But all that's going to do is give us either a 0 or a 1. So before we round that to an integer, what we're going to need is we're going to need to fit our random value from 0 to 1. Let's see, let me just pull up a fit range. And so this says our incoming value is 0 to 1. Let's make our outgoing value between 0 and 100 because we have 100 cubes. Okay? So now we've got random numbers between 0. Every time there's a value change, we get a random number somewhere between 0 and 100, and we are just making sure that those are integers. All right, now if we hop back up to that, and we just play this out, we're getting just what we would expect. Now, one thing about this that is really not so handy is that we see it. Let me show you in here. It was happening with our step values as well. There's these long plateaus, right? And for some things that could be useful, but a lot of times for me, what is better is rather than this hitting its value and then plateauing out until the next hit. So what we don't want these plateaus. We want to go from 0 to 1, back to 0, then at the next impulse to 2, back to 0, 3, back to 0. The way that I came up with to do this is just to compare channels, because ideally what you can do math functions in these VOPs as well. So what I would want to do, if the channel where its previous sample step is the same value as its current sample step, I can just subtract one from the other and my result would be 0, right? The way that I figured out how to do that would be to use a shift, and let me just delete or disable that. So now I have two overlapping channels, but I want to offset one of them just a little bit, right? And so now it's pretty clear to see where these values are overlapping. I just want that to be 0. So we come back in our VOP here, and similar, I keep saying it, but the same way that you would work in like an attribute VOP or point VOP, you can if you're in SOPs, you can say get attribute. Here you can say get. You can get attributes, but what I want is I want to get a channel value, and the channel that I want to get is let's see, my input index is going to be 1. The channel index is 0, and the sample index is this one, the same sample index as my current one. And what I want to do is subtract, not subnet, subtract. Let's see what that's doing. Is that close to what I'm looking for? So maybe I don't want to subtract. Let me see. Let's just compare. Compare. So when this value, when this value is equal to this value, I want, let's make a switch. So when it's equal, I want it to pass through, and when it's not, I want it to give me a constant value. I'll just make this constant value 0. Let's see if this does what I want it to do. Lost my. There we go. And that's looking more like what I want. So what this is telling us is that okay, this is saying that okay, when these two values, so in this VOP I'm comparing, when these two values are the same, so anytime this condition is true, output is 0. Anytime it's not true, like when these two things aren't the same, output its current value. And that's what I've got here. Right? So now I have exactly what I want. I have these sort of stair-stepped values. And if I look at my scene view again, you'll see that it blinks on and off. But you can see this is always going to point number 0. So that's not, all we need to do is just change this to -1 because there's no -1 point. Now let's check it out. Let me see if there's something I can do to give myself a little bit more of a plateau. This might not work, but let's take a look and see. All right, yeah, we can just stretch. We can just, oops. We can just offset our values a bit more so that we get longer holds per value. Let's take a look at that. All right, and then what we're also going to do is see what that looks like as a random value. And now we have random values, and when there's not a random value, we have a -1. And -1 meaning, again, since there is no -1 point, the condition of that group will never be met, so it's just off. And that's the basic setup for how to create a non-repeating random pattern based off of audio. Or if you would rather, you can also just create, once this loops back through, it's gonna be an ordered pattern. You can do whichever makes sense for your setup. I'm gonna leave this at the random pattern, and then I'm gonna switch gears to show you how to build that vellum grain setup that will be triggered based on this pattern that we just created. Back in our geometry context, using our random pattern, I'm going to drop down a sphere. So I'm going to use this sphere as a vellum grain source. I want this to be a little bit smaller because I don't want a ton of points for this setup, just for playing around. So we drop down a vellum grain configure, set this to create points from volume. Maybe that'll be enough. Let's see how many points we have. 297 points. So the first thing that we're going to need to do, and I would advise building out a few controls for this, and maybe we'll do it, or maybe I did it in my last tutorial. So we want to change this maximum value here to match the maximum number of points that we have, as well as this destination max. This is the fit range to give us enough random numbers to cycle through. So let's go ahead and make this a bit more procedural. So we want to say, we're going to do the same thing here. We're going to say that at id equals at ptnum. Okay, so now we have an ID, and what I want to do is do an attribute promote. So my detail, and this is going to be ID. So now I have a detail, but my promote is not average. I want it to be my maximum. So now I have a maximum there, but I also don't want to delete the original. So I have my ID attribute, which I'll use in another way as well. And I have a detail attribute, which is my maximum number of points I have. Pull in this geometry. Let me give myself a null. This is going to be let me go to capital letter, 2 chops max num. All right. So I'm just going to copy that, and in this geometry I'm going to point to it, and it is that is going to be static. And the channels that I'm bringing in, this is saying that I'm bringing in the position, which I don't want. I want my ID. Didn't like that. Let's see. Yep. So this is giving me the ID from every point. Let me leave this at detail. Okay. And then I'm going to do another attribute promote, and I'm going to say ID from detail to point maximum, and I'm going to call that max ID. So what I've done here, just to recap, because it's probably confusing as I'm muddling my way through it, I created an ID attribute from my point numbers. I promoted that to a detail, and my detail attribute says, and the promotion method I did it as a maximum, so that's always going to give me, no matter how many points are up here, this is going to give me the value of the biggest one, like the highest number. And then because in Chops it wants to bring in attributes on a point level, I just promoted that ID back to from detail to point and called it max ID. And now if I look at my geometry spreadsheet here, I have max ID, and it's always going to be the highest number of points that I have. So in my chop network, I'm going to say, let's do max ID, and I'll just call it max ID. And now I have a channel that I can reference inside my chop network that is dynamic, and it'll change depending on how many points I have, and it'll always give me my maximum number. And why that is important is on this count chop, rather than have this maximum be something that I have to type in manually, I'm just going to reference this in as a relative chop reference, and then I'm going to do the same thing down here. I'm just going to promote this the same way that you would in SOPs. Promote that so that it's available here on that. So, and then I'm going to grab this max ID and do a relative chop reference there as well. And what that's going to do is, I'll leave this where it is, and if I change this value to 0.75, all of these values scale with the number of incoming points. So I'm going to leave that at 0.5. Now I have random values. So now what I want to do is similarly to what I did over here. Actually, I think I can just copy this. I want to bring in that, oops, I need to do it after this. Bring in that, that step value. So now then I can see that I'm getting a random number. If you look over here, I'm getting a random number as I scale through. So what I want to do is, it's in essence, it's the exact same operations that I did over here. Everywhere this point ID is equal to my step value, I want there to be a group, and I want to change the color based on that. So let's see what that looks like. All right, so you can see that we've got our color happening the way that we're looking for. What I need to do is I need to use that that same value to increase our p-scale. Our p-scale is created in our Vellum constraints grain, or this configure grain. This particle size drives that, and you can see it down here. Let me just limit this. So what I want to do is, we've already done a little bit of work to get this nice like fading color. So I'm going to use that color value to add a bit to our p-scale. So I'm going to use a wrangle. Call this p-scale. Modify. I'm not creating the p-scale, it's already there. I'm just going to modify it. So I'm going to say at p-scale, that's saying that our incoming p-scale is going to be, I'm going to add a value to it from the X channel of our color. So we add our color value to it, but not the fullness of that color channel. We just want a fraction of it. So to do that, we say our color channel in the X value of our color channel times a channel that we're going to create. Channel, I'm just going to call this mult. All right. And by default that's 0, but when we just start to pull this up a little bit, you can see this point that's on the inside is getting really, really big. You just play through. That's probably going to be too much. We just need a little bit. Okay, but we'll leave it as that. Let's see. I think that is all that we need to do in this level. We need to put down a dock network, and we're going to build a Vellum solver. You know, you may be able to do this with the SOP level solver, but I found it a bit easier to do by building one out ourselves. So to do that, what we need is we need obviously a Vellum solver. Vellum solver. We need a Vellum object. We also need a Vellum source. And not in particles, we want that to go on our post stall. So let's get this set up here. What this needs is it needs the path to our geometry, and it needs the path to our constraints. In our case, we actually don't have any constraints coming in. We're going to see if it gets mad at us for leaving it blank, but we're going to do op input path. So you put one of those little back ticks that's the same key as your tilde key. Because that references the incoming, like what's up one level. Input 0, which is our first input, and that's got our geometry. And let's just see if we add a ground plane. Let's merge these together and then add a gravity, put that into our output, and let's see if this acts as we would expect. Yep. We need a constraint. All right, let's do a Vellum constraint. And we want this to be a glue constraint. So let's select glue. We want our group type to be points in both places. And rather than on creation frame, I want these constraints to be calculated every frame. And I want my search distance to be up to about 2. Let's see if that's, didn't seem like it was working. The constraints per point, let's change that to like 3. Okay, so that's probably too many. Take that to 2. Okay, so our points are sticking together. We're gonna update it and change a lot of these values. So we're just working on getting it set up right now. So the other thing that we need is we need to bring in our color, and we need to bring in our p-scale every frame. So the way to do that is with a geometry wrangle. What this does is it'll bring in something, a reference from SOPs, and then apply whatever you tell it to every frame via this this code block here. So the first thing we need to do is we need to tell it where to get our input from. So I want to use my first context geometry coming in because that's all I have coming in. But this is also it is what I want to reference. This has our updating color, and it has our updating p-scale. What I want to do is, let's just test this out with color first. So I want my color to equal, I'm going to just do a point expression here, and you can read this help to walk you through the syntax that you need for this point. But basically what I want to do is that at every point of my incoming geometry that I defined here, so this first input is going to be, that's where the 0 comes from. So at every point in my simulation, I want to reference the incoming point's color value. Put that in quotes. And then and then it says, how do you want to match these up? Just put this at ID. And let's see if this works. For some reason, I'm getting something double here. Oh, I know why. I think that it's just a viewport glitch again. Let me see. There we go. So you can see our points are changing, or the color is changing. And now I'm going to do something to completely break this, to show you something that I stumbled I really stumbled on for a little while. So we know that this setup is working because it works with our color. So we should be able to say, all right, do the same thing with P-scale. Here we go. Now this, you would expect that this would just work. And I'm going to save because I know it's going to break. And boom, it totally freaks out. And for the longest time yesterday and part of the day today, I was like, okay, this just isn't working. Maybe I'm doing something wrong. I went back to version 18.5 and rebuilt this, and it worked perfectly. And I said, well, maybe version 19 is messed up. So I updated to the latest production build, and it was still messed up. Reached out to some people on the CG Wiki Discord, posted the question, and somebody helpfully said, Bouncy Ferret helpfully said, hey, maybe try disabling some of the OpenCL options. So I know that the grain solver, the Vellum grain solver, looks for these neighboring points to create these constraints. So that was my first guess. Let me try that. So I turned that off, and lo and behold, we're working. It's not breaking anymore. We're getting these weird wormy things. Okay, so this is the big tip here. If you're having issues with this breaking and you're in version 19, turn this off to get animated P-scale values into your Vellum sims. All right, so thanks to Bouncy on the CG Wiki for saving me a lot of frustration there, where I was just gonna do this tutorial in 18.5. All right, so this is working. It's working great, but it's cool in some ways, but it's not really what we want. So let's just tweak a few values here. We're gonna turn on the breaking. So I want these constraints that are being updated, or they're being created every frame. When they reach a certain threshold, I don't mind if they break. So now we're not getting wormy strings going on. And also I know that this is not enough points to be an interesting sim, so I'm going to, the size of the sphere is okay. I just want more grains inside there. All right, now let's hit play. All right, still not quite there. This kind of stuff just takes a lot of playing around with. The other thing that I added in my first play around was a pop drag. The drag forces are pretty important for any kind of point-based sim. I think these are breaking too often, so I want to take my threshold maybe up to like 0.3 or 0.5. Let's see about that. Maybe my search distance needs to go up 3. Let me turn breaking off to make sure that my okay. Okay, so I think I'm going to make my sphere a little bit larger, and I want these to even be a little bit smaller. Get this working a little bit better. Let's go ahead and up our substeps. Or I'm going to leave the constraint iterations as they are. And these glue constraints, rather than each frame, I want to update these each substep. Let's just see what that gets us. Already a lot less explodey. You know what? I'm sure this is annoying. Sorry I didn't do this earlier. Let me just turn that audio off for the time being. I'll speed all this up. But it's really not a crazy heavy sim, but it is the more substeps and that you add, and when you start to calculate these constraints each substep, it gets it gets much slower than it was, but it's also much more accurate than it was. So let me turn audio back on so we can hear it. And that's pretty close to what I had. The main thing that I was struggling with this thing exploding was the substeps here, and creating the constraints each substep rather than each frame. So I'm going to leave that sim as it is, and then I want to show the last thing is how to get the color, how to deal with that in a little bit nicer way. So our DOPNet, as you more than likely know, will attempt to bring in every object that you have, and since I have a ground plane in here, it's bringing that back into SOPs. The way around that is it looks for object names. So if you just type vel, then anything that's like a velum object, the vel wildcard, what this wildcard does at the end of a text string is it grabs anything that starts with these 3 letters, and anything after that it just grabs. So rather than typing out velum object 1, I just do vel and that wildcard. So now we're going to talk about how to get the color in. So we do have incoming color. Like we can see those the ones where they're scaling up, they do have color. But what I'd like is I'd like that to sort of populate around them a little bit. So again, the way that I sort of thought to do this is in another solver. There's nothing but solvers in this walkthrough, but I think they make sense. So I'm going to pin my viewport and then dive inside here. What I'm going to do is do an attribute transfer, and this may. I think what I want to do is I want to transfer my attributes from the current frame to the previous frame, so I'm sort of accumulating those values a bit more. And now I think that's actually working. You can start to see some of that fading, but I think that I have this stuff cranked up far too high now. Let's see how this is working. All right, so that is doing what I want it to do. Let me just fine tune this a little bit. It's working great on the big splashes, like that one looks great. I just add more distance to it. Basically, say transfer that color within a higher radius. I'll probably get a little bit more. And I think that's fine, at least for now. And then what I like to do a lot of times is I'll drop another color stop after whatever color stop I have, and then I'll set this to ramp from attribute, and the attribute that I'm ramping across, I select my color, and then I can really push it. And that might be too much. You can dial that into taste. And then the other thing that's nice about it is you can change the color to whatever you would like. I think I had some kind of colors sort of like that in my original test, and you can play with it however you would like. But that's how I made it. And thank you so much for watching. I hope this was both quick enough so it wasn't boring, but also slow enough and thorough enough that people of any skill level could kind of follow along. So thanks again for watching. If you like this, give me a follow on Twitter. It's @whatifound, or subscribe to YouTube to get more updates. I'm trying to do these much more regularly than I have in the past. So thanks so much for all the positive feedback, and I'll see you next time.